Alright guys, welcome back. Hope all of you had a scrumptious lunch. Now, let's jump at the speed of lightning into the Lightning Labs. Lightning Labs are a series of mini intro lectures, workshops, and sharings. Let's introduce our first speakers, Terence and Xiang, who will be doing a short presentation of binary in real life. Okay, I think they are setting up their Lightning Labs, so please give them a moment for them to set up.
Hi, so meanwhile we're waiting for Terence to set up, let me give you all a riddle. You can write your answers in the chat if you want. Why was the queue met at a stack at a club? Anyone knows? Give you a riddle. I repeat the riddle. Why was the queue met at the stack at the club? Oh, is. Ace and Jun Hong got it right. Sadly, we don't have a prize for that. Okay. So, hello everyone, I'm Xiang and this is Terence from Nanyang Junior College. Brace yourself as we bring you on a lightning fast journey through the amazing world of binary number systems.
Ever wondered how computers represent numbers? Want to make more efficient use of your resources? Don't worry, even if you don't like math, it'll be fun to learn about binary number systems. So, firstly, usually when you look at numbers, you have about 10 kinds of digits, which is from 0 to 9. And let's say you have one digit position, you can actually represent up to 10 types of numbers from 0 to 9. Sorry, wait a while. Some tech. Okay. If you want to represent larger numbers, let's say, for example, you want to represent 12, you count from 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you move on to the next digit position to get 10, and then 11 and 12. And let's say you want to count above 99, you add one more digit position to get 100. However, in binary, you only have two types of digits. Why two types of digits? Well, this is because computers only know whether something is on or off, whether it's 1 or 0. So let's say you have only one digit place. In that case, there are only two possible states for it to be in, which is either off for 0 or on for 1. But what if we have two digit places? How many numbers can you represent? Well, you can start from 0, 0, 0, 1, then 1, 0, then 1, 1. So actually you have 4 numbers. So counting from here, 0, 2, and 3. One more digit place, you can count up to 8 numbers from 0 to 7. And so generally this is how binary works out.
So how can the binary number systems be applied in the real world? Do you know that unlike a regular digital clock, there exist binary clocks, which are also called the power of 2 BCD clocks. It is based on light-emitting diodes, LEDs, not 7-segment displays like a normal digital clock, and displays a binary coding of numbers in LEDs. So rather than reading a binary number, you infer it from an array of LEDs. Here is a picture of the binary clock showing 6:43. Looks really cool, doesn't it? Unfortunately, it is available on Amazon Prime at a high price of around $30, which is rather pricey. But how exactly do we read this complex-looking clock? Typically, 8 bulbs are shown with a lit bulb representing 1 and an unlit bulb representing 0 by convention. The bits are read from left to right to form a binary number. For example, the following image shows the binary number 001011111, which equals the decimal number 47. You could just as easily orient the bulbs vertically, reading the bits from top to bottom to get the same number. The powers of 2 clock is based on interpreting rows or columns of LEDs as binary numbers. The clock has 2 main modes, binary mode and binary coded decimal BCD mode. Each mode can be displayed in 12-hour or 24-hour time, resulting in 4 modes total. The clock has an arrangement of LEDs to cover all 4 modes, which means some LEDs will not be used in some modes. On the left, option 1 is the binary mode of the powers of 2 clock. Each time segment, hours, minutes, and seconds is represented by a single binary integer. In binary mode, the binary numbers are coded in rows. Seconds are on the bottom row, minutes are on the next row up, and hours are on the topmost row. We would then translate these binary numbers into decimals by adding up the powers of 2 to get the sum of each row, arriving at the correct time. Slightly differing from the binary mode, in the BCD mode, which you can see on the right, each decimal digit is represented as a separate binary integer. Since hours, minutes, and seconds are a maximum of 2 decimal digits each, 6 binary coded integers must be displayed. The binary numbers are coded in columns. Hours are on the left 2 columns, minutes are on the middle 2 columns, and seconds are on the right 2 columns.
And so here's another interesting way to use binary. So let's say you have 12 wine bottles. However, one of them is actually poisoned. And you have 4 reds. How will you figure out which bottle contains the poison in as fast time as quickly as possible?
Let's solve this problem together.
So at least comes to my mind will be just get each red to drink 1 bottle, isn't it? But no, we only have 4 reds. So I mean, we can only test the first 4 bottles. What about the other 8? Well, as I say, it's a binary workshop. So yeah, we must use binary to solve this problem, isn't it? So firstly, let's think about labeling all these bottles in terms of binary. So 1 is 1, 2 is 1, 0, 3 is 1, 1, etc., etc. Then 12 is 1, 1, 0, 0. You notice that you can represent all these bottles in terms of 4 digits of binary. What else is also 4? Oh yeah, the number of reds. So let's just match each red to each binary position, each digit position. And if we do that, the reds would drink the bottles in this respective order. So, for example, the rightmost digit is 1, so the green red drinks this first bottle. The second rightmost digit is 1, then the orange red drinks this bottle. So on for the blue and the brown reds. Let's say the blue and the orange red die. So how would you figure out which bottle is poison? Well, we just have to check our table of which reds drink which bottle. And blue, orange, reds drink the 6th bottle. So the 6th bottle has the poison.
Wow, with this knowledge, I think I can now become a detective. And with that, we have come to the end of our presentation. Hope you have enjoyed it and learned something useful about the binary number system. Thank you.
Thank you.
Thank you, Xiang and Terence, for the presentation. Wow, I never knew clause existed in this form too, and the puzzle really got my brain juice churning. And up next, we have Isaac doing a presentation on multi-threading. Isaac, please.
Hello, can you hear me?
I think you're a bit soft.
Oh, yeah. Hello.
Yeah, we can
Can you
hear
hear
you
me
now.
now? Okay, nice. Wait, I can't screen share. Hold on. Alamak, wait, I'm on Firefox. Hold on, let me just change to Chrome.
Okay, please hold on while Isaac is changing his browser.
Okay, so while Isaac is setting it up, let me ask you, Sam, a question. How about that?
Sure, let's go.
It's very simple. Why did the functions stop calling each other?
Because the recursion failed.
No, it's because they had constant arguments.
Oh my god. Yeah, nice one. Too many computing puns today. And I think my brain is already dead from all the quiz and stuff.
Stay tuned because we'll have more tomorrow.
Okay, hello.
Yeah, and I think Isaac is back.
Wait, can you all see the screen?
Yes,
Okay.
can.
Alright, then I'll start now. Okay, so hi everyone. In this lightning lab, I'll be going through multi-threading in Python. And multi-threading gives you the ability to run multiple tasks concurrently. What I mean by concurrently is to have multiple tasks run independently. So while task A is running, I can start task B. I don't have to wait until task A is finished. So one way of having tasks run concurrently is to have all your tasks running in parallel, meaning simultaneously, right? But because they're running simultaneously, they're using multiple CPUs, right? One CPU for each task. But this is a problem in Python due to something called the global interpreter lock, or GIL for short, right? So this global interpreter lock, right, prevents tasks from running in parallel. So why this is so, right, is due to how Python manages memory. Every time you create a variable, let's say we create a variable storing an empty list object, A, right? It gets this empty list object gets stored in your device's memory, right? But you can't hold that information in memory forever because it's taking up precious space. So you have to let go of the memory after you don't need it anymore. How Python achieves this, right, is through something called reference counting. All objects created in Python, like this object over here, this list object, has a reference count that keeps track of the number of references to that object. And when this count reaches 0, Python assumes you don't have a use for it anymore, and this memory occupied by the object is released. Let's take a brief look at how reference counting works. We can create an empty list object and assign it to the variable A. Then we can create a variable B, and we can set the value equal to A. And now we can get the reference count of A. And if we run this, we can see that it outputs 3, right? Why this is so is because this empty list object is being referenced by the variable A, the variable B, and the parameter that gets passed to this function over here. So it gets referenced a total of 1, 2, 3 times. So once this number reaches 0, right, it means that it's not being used in the program anymore. So that signals to your computer that memory is useless, and then it just throws away that memory, and you can never get it again until you create a new one. So the problem with this way of managing memory, right, is that when two tasks are running completely in parallel, it can increase or decrease an object's reference count simultaneously. And if this happens, it can incorrectly release the memory while references to the object still exist. So that's why we want to keep this reference count of all the variables, of all the objects, safe. Python does this by placing the global interpreter lock, a single lock on the interpreter, which keeps the reference counts of objects safe. But since there's only one lock, and the rule is that a task must get the lock to execute, it effectively makes all Python program running on a CPU single-threaded, meaning only one task can run at a time. Right? Python could use multiple locks, but that will mean a decrease in performance. Right? But what if we wanted to have multiple threads executing at the same time? One way to go about that is to remove the lock, but we won't go into that today. What we can do, which is a much safer option, is to go back and forth between tasks very, very rapidly to give the illusion that the threads are running concurrently. Right? There's a module for this in Python, and the module is called threading. So we can import threading. And I'll briefly show you how to use this module today. I'll be importing time as well, because we'll be using the sleep function to demonstrate concurrency. So the first thing you want to do, right, when you use a thread is to have a function, because threads can only execute a function. So we have to define a function and then initialize our thread. We can define our own function by typing the keyword def, followed by the function name, I'll call it sleeper, followed by the parameters where we want the function to take in. So in this case, I'll take in the number of seconds it sleeps as n. Right, we can print something like I'll be sleeping for n seconds. Right, then we can sleep for n seconds. And then after it sleeps, we can print I have awoken or something along those lines. So now that we have our function defined, right, we can start by initializing a thread. We can initialize the thread, we can name it in this case T, by calling the threading module. So threading. We can call the thread class within that module, so threading.thread. And this, the T of this thread has to be capital letter. When creating a thread, there are a few parameters we need to be aware of. Right? The first is the target. So we can type target equals. And the target is the function that we want to execute. So in this case, we want to execute this function over here, which is called sleeper. So we type in the name of the function sleeper. The next parameter will be args. And this will just be the arguments that this function takes in. So in brackets, we can place the parameter n. So in this case, maybe we want it to sleep for 5 seconds. But notice how if I put one parameter over here, right, it won't work. Because the args variable, right, has to be iterable. That means you have to be able to iterate through it. So if you had multiple parameters, right, let's say I wanted to also take in the name, right, and if you type this will be okay because this is a tuple and you can iterate through the values in a tuple. But when you only have one value, right, you cannot iterate through anything. So what you have to do when you have one value is to just make a list and then wrap that object in a list, just like that. So after we've initialized our thread, this is it already. We can just start running the thread by typing the name of the thread, in this case t.start, like that. And this will start executing the thread. All right, if we type in like random print statements over here, like print wake up, right, we can print that like 2 times. And if we run this now, right, oh, invalid syntax. Alamak. Sorry, I was playing with JavaScript just now. See, you can see that it sends hi, I'll be sleeping for 5 seconds, right? And I've awoken. Like what? If you just type out a function and just call that function over here, right? What you would do is you'll print this first, you wait, then you print this, then you'll print this too, right? But in this case, right, since the threads are running concurrently, it prints them at the same time. So it prints wake up and hi, I'll be sleeping for 5 seconds at the same time. Then it prints this wake up over here. Then after 5 seconds, it prints I have awoken. So you can see that the threads are actually running concurrently. They're running at the same time. So you don't have to wait for the sleep function to be over. Then you can print wake up. Like they run at the same time. So there are many uses for this. I'm sure you can find some use for it. It's useful if you want to like output things at the same time, even though they have different like execution times. But yeah, that's it. I'm sure you can find a good use for it. Thank you very much. I'll see you again soon. Thank you.
Well, for some reason, I thought it would be about sewing, but who knew multi-threading was so interesting? Next up, we have Zhe Zhao doing a sharing on automation. Zhe Zhao, please. Oh wait, someone has a question about multi-threading. Isaac, can you check the Google chat? And so I can share, I can start a presentation. We can't hear you, by the way.
No, that's how we can't hear you.
No, we can't hear you.
Can hear now?
Yeah.
Can, right? Okay.
Can.
Wow, so many. Okay. Okay. Hi everyone. I'm Zhi Zhao, and I'll be presenting a line lab on automation. So, I will be sending the slides over inside the Google Meet. You can go refer to them if you want. There's some links inside. And okay, so about automation. Last year I was at PyCon SG19, right? And there was this guy talking about robotics process automation, and I thought it was really interesting. But it turns out that it's not anything new to me because it just involves like pressing stuff on the screen now and connecting to like opening URLs and things, simple things like that. But then I realized it's very important today because automation is becoming a key to our everyday lives now. So a video from Kurt Skizat, it's a popular YouTube channel on stuff like this. Actually, on a lot of things. But you all can go check this video after the.
Zhe Zhao, I think
after all the labs.
the link you send needs access.
Needs access. Oh, sorry.
Also, can you press hide later?
Oops. Keep forgetting. Wait. How do I change the anyone can link can view? This is the last link. This is the one at the bottom. Okay, so with that, right, I would like to talk about two different types of automation on computers. The first type is there on the UI level, which is more robust but it's only applicable to certain software. And the second type is there on the level of HID or human interface device, which means like the computer simulating touches or presses on the keyboard or mouse. And it's more flexible, but it tends to be less reliable because of wait times and stuff like that. So here are some softwares that utilize these two processors. The first is they are Selenium, Temper Monkey, Python GUI or Python Auto, Tech UI, and Automator for Mac. And on the HID level, we have AutoHotkey and PyAuto GUI or PyInput. And so I'll be demonstrating what PyAuto GUI can do because, okay, so basically, right, PyAuto GUI allows you to interact with the keyboard through Python. And what I made here is a demo where in this race is not very good. So let's say I go to typeracer.com and I want to type very fast. I go screenshot the letters, and I save this. And I save this under OCR, which is snapshot.png. And let's say when I run it, say typeracer.py, and I go here. It's not running. Oh no. Yeah, you can see that it's typing very fast. And this is one of the hacks I use, or it's just the fundamental project I made that involves the usage of where is it? That involves the usage of PyTesseract and PyAuto GUI and PyInput. That makes it's a typing bot law. And another demonstration that I want to give, which is on Temper Monkey. It's basically a simple demo that allows you to edit the web pages or basically anything on the web pages that you want using JavaScript. So let's say I go to BuildingBloCS website, right? And I see all red. Let's see the thing, sorry. Let's see, I see everything's all red. I don't really like this. Then what I can do is I can write some JavaScript code using Temper Monkey. And say I set my favorite color to green. And I want to change all of the elements with a tag name, well, with a tag of A, and I want to change all of them to have a favorite color of green. So if I run this now, and I reload the website, you see that everything becomes green. Wait, some of the buttons and some of the things, they're very ugly. So what else you can do is, I know it requires a lot of like editing and manual stuff, but then it works. But once you get it done, everything else is very smooth really because most websites have the same classes and stuff like that. So if I do this and now I run the code, let's see now everything is green and the buttons and yeah, and the entire layout of the BuildingBloCS website is green now. So Temper Monkey is actually a really cool tool that you can use to enhance your browsing experience. In fact, that's actually how dark mode extensions or ad blockers work. They work by adding on JavaScript to edit the client-side web pages. Yeah, so those are two simple demos on how automation can be implemented in your daily lives. And I've included some links here. And if you all have any ideas or if you all have any things that you think can automate, you can submit them in the form I provided inside the Google Slides. And you may or may not increase your chance in the future lucky draws for tomorrow. Yes, thank you.
Thank you, Tata. That was a good presentation. I wish I could automate doing my homework somehow, but oh well. Have you guys ever heard of the tortoise and the hare? Have, right? The tortoise went slow and steady, and he won. But have you ever seen a lightning turtle, or even a lightning tortoise, or even a lightning turtle? Well, let's welcome our next presentation on lightning turtles.
Hey, Rose, can you screen share? Thank you. Oh, yeah. Okay, so hi guys. This lightning light is slightly special because it's actually in two parts. The first part is going to be a 10-minute workshop. Okay, ignore the word workshop video. This is a workshop. The 10-minute workshop conducted by Rose, the person screen sharing right now, going through the basics of Py. After that, there will be tomorrow competition actually based on today's workshop slash lab. So tomorrow there'll be a competition which will give you a theme, and using Py, you have to draw something related to the theme. You can draw anything as long as it's related to the theme. So what you need to submit tomorrow is the drawing, the explanation on how your drawing fulfills the theme, and the Python code. And if you're working with your group members, basically your Discord group, explain how you all work together to come up with the design. Yeah. Okay. Any questions can PM me or type in the Google Meet chat. Okay, Rose, can you conduct the workshop? Thank you.
Guys, if you have either or any editor on, you can use it now. So first of all, we're gonna import turtle. And then we're gonna set a variable called t.turtle. Right, so that we don't have to call the function turtle.something every single time. Instead, we're just gonna call
It's
t
not
dot. Sorry?
Your module is spelled wrongly.
Oh, sorry. Okay, then we're gonna change the shape into turtle. And then also the color. And then the pen size. So the pen size is actually the thickness in pixels. And in order to see what's happening, we have to input like some commands. So for example, t.forward 40 pixels. Okay, so we move forward by 40 pixels. And then now we're going to decrease the pen size. 1, and it moves backward by 80 pixels. Yeah. So you can see that the pen size decreases, and you can just change the pen size if you want it to be thin or thick. And then now we're going to introduce angles. So t.left actually turns it into an anti-clockwise direction. And then we're going to run it and see how it goes. Yeah, so it turns 60 degrees from the horizontal anti-clockwise. And then we're going to show right. And then this one turns into a clockwise direction. So it returns its original position. And then now we're going to remove the line, which is t.10r. And then sometimes I think depending on your editor, you might need to put pen down again. And then now I'm gonna try to increase the speed. T.speed. So the larger the number inside the parameter, the faster it will go. And then we're going to set the end position. It is t.set cost x and y. So if you set it at 0, 0, it will actually give you the center of screen. So you can see that the end position of the circle is at that coordinate. And then we'll try to do circles. And then the radius. So t.circle and then the radius. Okay, now it's like we are going to add colors into it. So t.color, we have red and then yellow. So this means it's actually stroke, comma, filling. So we have a red stroke and then inside it will be a yellow filling. And then we need to add in t.begin. So we'll change the radius size of the circle, make it a little bit bigger. And then t.end. So yep, so now you have an outline of red and inside it will be yellow. And I think we have time for one more, which is squares. And it use for loop. So for I in range for t.forward 100, t.left 90. Okay, yeah, so the square. Okay, that's the end of the sharing now. And if you're interested to learn more, you guys can find the links to the GitHub pages sent in the Discord, I believe so. And there's also a video in there. So good luck for the competition and may the most creative coder win.
Okay, wait. Let me clarify something. So the tomorrow's competition or competition, right, is you can work individually or you can work in your Discord group. I think you get more lucky chances if you work in your Discord group. So yeah. The theme for the what you need to draw will come out tomorrow in the opening speech.
Okay, thank you for the presentation. I'll definitely be playing around with Lightning Turtle later. And with that, we have come to the end of day 1 of Building Blocks Finale Conference. All talks and workshops have been recorded and will be uploaded onto our YouTube page. So guys, thank you for coming and see you tomorrow. Any ICs want to say anything before we end?
Okay, yes, thanks everyone for coming, and we apologize for any technical difficulties or like lagging or whatever. We'll try to resolve most of that for tomorrow's conference. So yes, everyone have a good rest of the day, and we'll see you tomorrow again at 9 a.m. Yes.